stuff, preparation.
So honestly, I had a hard time this week because in the preparation assignment, I didn't know where they were getting their numbers.
Oh, really?
Yeah. Like in the answer key, I didn't know where they were getting it.
That's happened to me a lot. I'll be honest, I didn't even look at this. I just saw it was review, and I was like, oh, well, I'll just go to the meeting. Which I probably should have done that. But.
Lesson 7's not a review. Lesson 8 is.
Lesson 8?
But we're on lesson 7.
I didn't look at lesson 8. I looked at lesson 7.
Lesson 7's not a review.
What?
I'm pretty sure it's not a review. Okay,
Did you get the videos for the preparation?
No. I just read the textbook.
Oh, well, we're in trouble then. Because I looked at the videos, and usually the videos correspond with the reading. And the videos were just like reviews of chapters, all the chapters we've gone over.
Which videos? The ones connected to the textbook or the ones that the teacher does?
The ones, let's see. Lesson 7, part 1, I pulled it up, and it's review of chapter 5, review of chapter 6, and then finding the area or probability within a distribution of sample means.
Yeah, so we're still using like the z-score and stuff, but they're changing it.
Oh, well, that's good of me. I'm sorry. I just said that, and I was like, oh, I'll be fine.
Yeah, they're changing it to be like the sample means or whatever, however that is.
Oh, so what we did last time times whatever. Well, I guess I'll be reading as we talk.
Well, I just had a hard time because, like, did you do the preparation? The first part?
Mm-mm.
Okay.
But I can quick.
Why don't we just do it together?
Okay. Might as well.
Because I did not know where they were getting their stupid numbers from. Okay.
One of them.
Pull up the answer.
I have my calculator. Hold on 1 second.
Okay.
Okay, lesson 7 preparation. One of the two conditions must be satisfied in order for sample mean to be normally Are we doing preparation 1 or the first part?
Yeah. So that was from last week.
From last week? Lesson 7, right?
Yeah, I mean, that question was a review from last week, what we did last week.
Oh, okay. Oh, yeah, okay.
Yeah.
The two conditions are that the parent one has to be normal or it has to have a great sample size, right?
Yep. Yeah,
Okay.
That's what I put.
What is the z-score formula for a sample mean that is normally distributed? Isn't it z equals mean minus the standard deviation?
No. So that's where it changes. So like the z-score that we had before.
Huh?
Oh, shoot, what was it?
Oh, okay, I see it. It's z equals value minus mean over the standard deviation. But I have it with the square root.
Yeah, so for the population, whatever it is, or this week it changed. So now let's see if it'll let me copy and paste it. So it's like the x with the little line over it, minus the mu.
Okay.
Over sigma, I think, but the little standard deviation thing.
And then divided by
the square root. Yeah.
Okay, I have that.
I don't know why it changed, but it did.
That was last week's or last time's. I thought. Maybe not.
Yeah, we talked about it last week. Maybe.
I think we did. And by last week, I mean last lesson.
Yeah. Anyways,
Okay.
so then number 3 is where I start getting tripped up.
Okay.
So it says, you can
Sorry. Suppose a normally distributed population has a mean of 10 and a population standard deviation of 5. What is the probability a randomly selected individual is between 5 and 15? This is from less than 5.
So I got that one. That one was fine. So I put 68%
Okay.
because of the like empirical rule thing.
Yeah, are you just supposed to put both of those numbers in the z-score?
You don't even have to do that because the mean is 10
Mm-hmm.
and the standard deviation is 5, so it's one standard deviation both ways.
Oh,
So-
okay.
68%.
Then what is 40th percentile?
So B is where I start getting tripped up.
68%. Do you need to put it in the applet?
For B?
Yeah.
Maybe. Because on the answer key it says 10 minus 5 times 0.25335 equals 8.73325. And that doesn't make sense to me.
Let me look my notes here for a second. I remember learning that percentage, but that kind of the probability part of z-scores kind of threw me off. I wasn't very good at it. Wasn't that where you put it in and you minus or subtract it or something?
I mean, if you put just 40% in the probability app thing, it gives you a z-score, but it's not the same.
Mm-hmm. Was that lesson 5 that did the z-scores?
I don't know.
Yeah, it was. Okay. I'm going to see if I can find that. Formula and stuff. I'm going to be screwed for this test if I don't have this all memorized. So I've been like a few days and already like, I don't remember how to do that.
You get notes.
Oh, we do? Oh, good.
You get like 1 page of notes or something like that. I mean, it's limited, but still. I just don't know where they're getting that number from.
Let me pull up the key, because usually when I read a key, I understand it better, which is weird, but.
Well, and I do too, and that's why when I was looking at the answer key, I just didn't even make sense to me. Like, where are they getting the 0.25335? And why are they multiplying?
Oh. Wrong one. Okay. Ooh. Okay. Ten minus 5.
I mean, we don't have enough information to calculate the z-score because we don't have the sample size.
Yeah.
So it's really not going to be. I don't know where they're getting this answer.
Yeah, I can see where I'm like, wait, 10 minus 5 isn't. It's the. Leanne just texted us, sorry. Okay. I am going to look for that because there's a formula for doing that. I'm wondering if I put it in the applet and got a number, but I don't know. Um, I have no idea where they got that. Run!
I'll be right back.
I'm trying to find the information to even.
I mean, and even up top it says use the information from the reading assignment, but even with that information, it doesn't make sense.
I don't know what that is. I remember it being like a formula though, so I'm trying to find that formula. Probability between numbers.
I mean, from everything I could find, we have to know the sample size.
Yeah. I have no idea. I have no idea. Can I just go on to the next one?
Well, that one doesn't make sense either.
Oh, really?
Because you can't find the z-score without the sample size.
But isn't the sample size 18.5?
I thought that was x, the variable. Am I wrong? I could be wrong.
Lately, I've been the one that's always wrong, so I'm sure you're the right one.
I don't know, maybe, because x is supposed to be the mean. The
Z-score is X, so Z equals, isn't it 18.5 minus 10? All over 5?
square root of what? We don't have a sample size.
But it's just a Z-score.
Yeah, but the z-score it has for this lesson is x bar minus mu over whatever it is, sigma, over square root of n. But we don't have an n.
Oh, I see what you're meaning.
Let's see, and we look at the answer key anyways. It says it's 1.7.
That's what I got. You
How
just
did you get that?
just do a regular Z-score. Z equals X minus mu over standard deviation.
So you did 18.5 minus 10 over 5.
Mm-hmm.
Okay. I don't even.
That's why I was like, this is kind of a skewy chapter because it's kind of mostly review, but then there's a slight new chunk.
Okay. So we just need to find the z-square of 12 then.
What is the probability that the greater than 12? I have a question for you. So this question here, it says, use this information. Okay, so what information from the reading assignment do we know? It says, suppose a normally distributed population has a mean of 10 and a population standard of 5. What is the z-score what is the 40th percentile for this population? When we looked at the key, we're really confused because we're not sure where they got this number. The 0.25335. I guess it could be in the reading, but
So D doesn't make sense if we it just doesn't make sense. Okay, bam.
Yes.
Okay, come look at this one.
I love that we had to pull the men in on it.
Okay.
Hello, people.
So they're asking for the 40. Okay, so this is what we've covered. So the z-score for the sample mean is this formula right here.
Mm-hmm.
Okay. So then it's question 3. So suppose a normally distributed population has a mean of 10.
So it's saying it's in the reading, but I don't even know where it's at.
What is the percentile for this population? How do we figure that out? I think there's nothing to do.
I think too.
I'd imagine. Does this first? Let me ask this. Does this represent your 68%? Or is that?
Yeah.
Okay.
Because it's 1 standard deviation.
Okay. So if what formula did you use?
I didn't.
My husband thinks it could be the applet.
The empirical rule?
Yeah. Because it's 1 standard deviation, but it's 68%.
Are you supposed to use the empirical rule for that one?
Yes.
Okay.
So the answer is about 68% using the 68, 95, 99.7 rule.
Okay. Let's see. So
So I should be able to use that.
what's the 40%?
So I can use the applet, I think.
I wish the applet was just easily accessible.
Have you not bookmarked it? It can be. You can save it to your desktop.
Think about that. That could work.
So you should be able to put 40% right here. But it would be this area.
Yeah. Okay.
That doesn't, so that just gives me a z-score, but it doesn't tell me what it is.
So you've got a formula.
Oh,
Did you figure it out?
hold on.
That makes sense to me. That's what I would do.
Okay.
You can hear a breakthrough in your voice.
Maybe.
Excitement unlimited.
Ah, there it is.
So, right?
That's what I would do.
Okay, now does that match? They have. Praise the good Lord! I got it.
How'd you do it?
So you have to do it backwards. So you do. Okay, so you take the applet, you type in 40% up at the top, and that gives you the z-score. So then you take negative 0.253 equals x bar minus 10 over 5. and solve for that. Jeez. Okay, you have to stay here.
So
I know. Does that make sense?
hold on, I'm just trying to get the 40.
All the stuff is right here, so.
Oh.
Yeah.
That's nice.
You put 0.40 in the top, right?
Yeah, so that's the 40th percentile, and you only highlight the stuff on the left. Because you want everything below that.
So only the left part.
Only the left. Thinking about kids' heights. 40th percentile is you're taller than 40% of the people, so
Okay.
yeah.
I didn't get the 0.225 though. I got,
negative 0.253.
okay, that's weird because every time I put 0.40 in the applet,
Up at the top.
okay, there it goes. So negative 0.253.
Yes. And then you do your algebra for that. So plug that into the formula and then solve for x bar. Thank you.
What's the formula again?
So it would be x bar minus the mean, which is 10, over the standard deviation, which is 5.
Oh, gotcha. Gotcha. Okay, so x minus m, which is 10, over 5.
Yes. Because that was the information we were given.
I just lost the negative sign on my calculator. What the crap? Where'd that go?
Hold on, I'm not getting exactly the same. How do I do? Oh my goodness.
What was their answer again?
Hold on just a sec. Because I think that rounds to the third decimal.
They do 10 minus 5 times the number.
Yeah, because when you're doing your algebra for it, you take maybe more sense. I'm still not getting the exact number they're getting, but I'm getting close. Even on this, 735 instead of 73325.
I'm just looking for the right formula we're supposed to use.
Yeah, but I have it rounded to maybe 0.253, so that's why.
Yeah, that's going to be causing that.
Okay. I don't know why.
They're not going to use the z-score formula to
They're not-
find probability.
See, if you use the value they put in with all the extra digits.
Okay, does this make sense to represent this?
Yes.
Okay, how?
How? Oh, is this is the one
This
you just
one.
did?
This one right here. The one, this one,
This one.
this one, B.
Yeah.
Because you do this.
So we did it backwards. So we would have put in the z spot we would have put the negative 0.254. And then would have put equals x minus 0.2 or x minus the mu, right? 10 all over 5.
That's what I have. Except I have negative 0.253, not 254.
Oh, that's what I meant to put. I must have. I don't know why I put 4.
Why does that make sense?
Oh, and then you multiply both sides by 5,
Mm-hmm.
and the 5s will cancel, right?
Yeah, it cancels the 5 on the right side.
So we're left with 5 times negative 0.253 equals x minus 10.
This is what it is. To just switch those two positions because it's addition.
No, but they have 10 minus 5 times.
Well, that's the same thing. This is multiplication. These are multiplication. It doesn't matter what order you multiply. 5 times 2 is the same.
Where'd you go? That was weird.
It said you lost connection.
Oh, weird. It doesn't get the number that they said.
They have 0.873325. And I have 8.735. And that's because the z-score that they have is 0.25335 and we have 0.253. That's where we're getting the difference.
Okay. That's weird. Whatever, we got it right.
Yeah, I think so.
So we did see D. What is the probability that an individual observation is greater than 12? So my husband taught me this, and it kind of made sense. But
How was that the answer?
My husband's laughing at me
I'm not laughing. I just asked quizzically.
because I did this.
Oh. Yeah.
we should just make the husbands do it, and we can go do something else.
You hit the clear button.
I didn't.
Do it again. Yeah, instead of hitting verify, you hit clear.
Whoops.
You hit clear.
Well, whatever.
Evidently twice in a row.
That's still not the right answer anyway, so it doesn't matter. Okay, so for D, we do 12 minus 10 because they're giving me the 12 divided by 5. So the z-score equals 0.4. And then you plug that into the normal thing, right? 0.4, the probability app.
The one we just did.
And so when you plug it into 0.4 as a z-score in the normal probability app, you get 0.3446.
Right. That's right.
Okay, so I got that.
So,
What is the probability that an observation is less than 8 or greater than 12? So you're supposed to... Hey, Ron, come here.
So greater than 12 we already have. So now we just need to find less than 8, right?
Mhm. How do you find that?
So it should be 0.6892.
Hold on, I don't even know how to do it. I'm gonna ask my husband. How do you do probability finding less than 8?
So it's the same thing.
You
Now,
just
so on your probability chart, probability output, whatever, just highlight the blue side on the left side. So leave the middle white and then the blue is on the right side.
you just put 8.
There was probability being less than 8 or above 12. So
So you put on the left and the right.
Mm-hmm. Because the z-score for 8 is negative 0.4. So it's the same.
For the 12. You got 0.6892.
Yeah, and that's the answer in the thing. In the answer key. 0.6892.
Oh, okay. Gotcha. Gotcha. Okay.
Well,
Yeah,
thanks for helping through that with me. That helps.
this is taking forever. I'm ready to just take this stupid quiz. Oh my heck. Now looking at it, I really want to.
What does it say?
Oh no, it's just 15 questions.
Well, part 2 should go by pretty quickly. I think. Maybe.
Let's see. Let's see. Part 2. Samples of size n are taken from normally distributed sales data. What is the shape of the distribution? Normal. 5. Sample sizes of 40 are taken from normally distributed. Normal. Sample size of n. 4 is taken normally distributed. What is the probability that x is less than 4? Is this what we learned today?
I think so.
Less than 40?
Yeah, so you do find the z-score for 40.
Okay. I get some blank paper here so I can write down my numbers. Yeah, but we're not given a standard deviation.
We are. It's 10.
And the mean is,
45.
where are you getting this information? Oh, it's right there. Okay. Like, what? 45 and 10. Okay.
So the z-score should be negative 1. So do that.
Put that in the applet. And we're saying less than 40.
Let me check my answer real fast.
So we said less than 40, so that means just the left side, right? Not the middle.
Well, it wants us, according to the answer key, it wants us to use the probability, the empirical rule. Ooh.
Statistics.
But 1.587, so everything left to negative 1. So that's what I got.
So that's what I got. Okay, we got it right.
Yeah.
Sample size of n is taken, normally distributed. What is the probability that x is greater than 35 and less than? The Bailey z-score for 4 is -1.
I didn't hear what you said.
The sample size for 4, what's the probability? Sorry, just lost it. Greater than 35 and less than 55.
Okay, and let's see what else.
Oh, z-score -2.
So it's 2 and -2.
Yeah.
So we want, what is the probability? Greater than 35.
Less than 55. How does that
That
work?
would be the middle. So 95 or 0.9545?
That's what I think. Let me look at the key. Yeah. That is right. Okay, a sample size of 25 is taken from a normally distributed sales data. What is the probability that x is greater than 41 and less than 49?
Okay, so 41.
Did you do -2?
Hold on just a sec. So it should be the same, right?
Like that.
Yeah, it's the same for 8.
Yeah.
9545. Yeah. Okay.
So sample size for 25 taken. What is the probability that is observed greater than 50? So just the right side, right? Not the middle?
Yeah.
0.0228? No. Not right.
So it's 2.5. So greater than 2.5.
Isn't the z-score the same though?
Not for the next question.
For 9?
So it should be 0.0062, right?
Yeah, but if the number is 25 minus 10 over 5, or minus 20.
It's 50 minus 45 over 10 to the square root of 25. Or divided by. Right?
Oh. 50 what?
So 50, which is they're saying greater than 50. So it's 50 minus the mean, which is 45,
Huh?
divided by 10, which is the standard deviation, over the square root of 25, which is the sample size.
Oh.
So that's 5 over 2, which is 2.5. So you type that in and select the one on the right.
You have it right.
62. Daddy's coming, baby. Hold on. So, 0.006.
I guess I'm just confused as to when you're supposed to use the regular z-score and when you're supposed to use the standard deviation or the other one.
Yeah, I don't know.
Because you did it the right one and I just did the z-score and I got it wrong. So I'm like, what? How can you tell? Okay, whatever. Sample sizes of n equals 4 are taken from the right skewed 2010 p-point cells. What is right skewed? Samples size of n are taken right skewed of 40, so that's going to be a normal skew. Is there a theorem that justifies answer 11? What is the name of it? Central limit theorem. Am I moving through too fast for you?
I'm on 14. So I got, for 10, I got right skewed. 11, I got normal. 12, I got central limit. So yeah, I'm just agreeing with you.
I'm like, okay, I'm just going through these. Okay.
No,
From a right skewed. So are we using the same numbers then, the 45 and
Which one are you on?
14?
What did you get for 13? I didn't hear you answer that one.
Oh, I didn't. 13. Okay, sample size 4 is taken from a right skewed 10,000. Let's see. Sample size n equals 4 is taken from a right skewed 2010 people associated and the probability that is observed.
So I put that you can't compute it because it's not normal, and the sample size isn't big enough.
Yeah. That's what I would say because it says it's.
Okay, so
Yeah, it won't work. So a sample size of 36 is taken from the right skewed 2010 p-phone cells data. What is the probability that is observed? X is greater than 36.5.
So we're using the information. It says pair computing sold an average of 40 p phones per minute. So that was our mean. The mean is 40.
Okay.
With a standard deviation of 12. And it's right skewed. So, and then our sample size is 36. So, and we're asking about 36.5. So I put 36.5 minus 40 over 12 divided by the square root of 36. Let me see if I'm right. Okay, and I got it. So the z-score should equal negative 1.75. And typing that into the applet, selecting everything to the right, 90 or 0.9599. Is that what you got?
Hold on, I'm writing it in right now.
Okay.
12, oh, let's see, 12 divided by the square root of 36.5, right? Oh, no, 36.
36.
What's
Yeah.
X then? Is it X?
X is 36.5, or X bar.
Okay. That's what I was just thinking. Okay. Sorry, I'm slow.
No, it's fine. I'm normally, yeah. I didn't even get half the questions at first, so thank you for going through them with me.
No problem. I need all the studying I can get.
Okay.
What did you get?
For 14?
Yeah.
0.9599.
Okay. Let me do parentheses here. 36.
Oh, for the z-score,
Yeah.
negative 1.75.
Divided by 12. Okay.
Pretty sweet. You did that thing, kid.
36. You got negative 1.75?
Yes.
Okay, that's what I got.
That's a regular test. That's so precious.
So did you just put it in the applet? Well, you can't put it in the applet if it's right skewed. So how did you find the probability?
I did because the sample size is 36, so it's normal.
Oh, okay.
Look at this. That's
It's greater than. Okay, so it's gonna be just the right side.
Yeah, so it would be the middle and the right side.
So 0.9599.
That's what I got. And that's what the answer key says.
Good. The sample size 36 is taken from a right skewed to the left. What is the probability that the observed x is between 37 and 42? 37 and a half. So do you have to do this twice?
Yeah.
Both women? Okay, just checking. So Z-
The first time with x bar equal 37.5, and the second time with x bar equaling 42.5.
Okay. So the first one I got negative 1.25 is 37 and a half. The next one I got
okay. Get Daddy kissing.
What?
oh, okay. I got it right.
She can watch her movie. Ratatouille. Oh, Laura, look at Mama. Hold on just a sec. You want to watch this book and movie?
Yeah?
Yeah. You want to watch this movie about mice?
Yeah. I know it.
I know you do. You see her dancing? Okay. So we should be done. I mean, besides the quiz, right?
Right.
Okay, so let's open that up.
Yeah. Got 15 minutes.
Let's watch.
Okay.
You see the mouse?
Let's get this beastie finished. I can be done with my
He's actually a rat.
He's a mouse.
group meeting.
You're right, he's a rat.
It's called Ratatouille instead of Mouseketeer.
Ratatouille. Okay.
It's not.
Use the probability, the normal probability outlet to find the combined area under the standard normal curve that is to the right of Z 1.358 and to the left 1.3.
What week are we in? 6? 4?
We're in week 3.
Week 3.
Just,
Feels like it's that long.
oh, jeez. Okay, let me open this. Because I know.
0.358.
So lesson 7. Yeah, lesson 7. Okay. Oh my gosh.
To do a lot of freaking homework. Okay. So probability applet. Okay. Find the combined area under the standard normal curve that is to the right of 0.358 and to the left. Okay. So 0.1745. So rounded, it would be 0.175.
Hold on a second. Let me think about this question for a minute. I haven't thought about it. Okay. So I'm going to the right. Okay, so right and left. What did you get?
0.175, but I'm only confused because it says area under the standard normal curve too. But that is to the right and to the left. 0.175, right?
Yeah.
The United States Coast Guard assumes the mean weight of passengers commercial boat is 185 pounds.
Can you say gratitude?
Previous value was lower, but was raised after tragic boat accident. Standard deviation of passenger weighs 26.7 pounds. Find the probability that a random sample of passengers will have a weight.
You skipped a line.
I did. The weights of random sample of 48 commercial boats were recorded. Sample mean was determined to be 177.6. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, and was observed in the sample. Round your answer to 3 decimal places. I'm not even sure how to do that.
Hold on just a sec. I think I do. I think we do X bar is equal to 177.6 minus the mean, which is 185, over standard deviation 26.7 divided by the square root of the sample size, which is 48.
26.7 divided by the square root of 26.
Square root of 48.
Oh, 48.
So
Oh. Negative 1.92.
that's what I got. So let me think now, because now we have the z-score for above or below.
Amazing how much harder it is when you only have 2 brains to think it out
I know, right?
instead of 3.
To me, this means because it's asking the percentage of above or below. To me, it would be 100%. Because
Wait. My husband knows this one. He tried to explain this to me the other day, and I did not remember ever reading it. And
What are your thoughts?
I think it's this type of question. I have to run that by him.
Too bad you're not watching it now.
What?
This question number 4.
Question 4.
Okay, so show me what you've done.
This. So the mean of 185 standard deviation, 26.7. Sample size N is 48, and X bar was 177.6. So I just found the Z-score because I didn't know what to do.
Okay, so then the Z-score, that gives you,
Negative 1.12.
okay, so did you put that into your applet?
No. Now what? Because it wants everything above and below. So for me, that would be that.
Go back to that. This tells you everyone. I mean, this gives you, this area is people below that extreme. This area is above that extreme. Is that not what you're looking for?
Well, it says find the probability that a random sample of instances will have a weight that is as extreme or more extreme, either above or below the mean, as observed in the sample. Oh, okay.
Perfect.
So it would be 0.0549, right? Is that what your husband got?
Is that what I got? What?
0.0549.
Wait, how did you get that?
Okay, I don't even know how to explain it. Because it wants to know the extremes. So we found the Z-score to be negative 1.92.
Mm-hmm.
So we type that into the Z-score thing on the left, negative 1.92.
Oh, in the applet?
Yeah, and you highlight the sections on the ends and not the middle, because it wants to know the extremes, right?
That's what I thought, but I wasn't sure. So 0.0549.
Yeah, is that what you got?
Mm-hmm. So
Okay.
0.055.
So, yes. Okay. So yeah, that makes sense. Maybe.
We'll find out.
We'll see if we get it right.
Okay.
Which of the following have a smaller standard deviation if 9 observations are randomly drawn from a population?
Distribution of the individual observation.
Maybe A?
I don't even know. Like, it doesn't give me numbers to work with on this one.
Yeah, it's just theoretical. 9 observations randomly drawn from the population. Sample meters should be closer. Michael? I'm thinking A. Is there an obvious reason not to think A for 5?
Which of the following have a smaller standard deviation if 9 observations are randomly drawn from a population?
Don't say population.
if I had to pick, I would probably pick A.
A is
Well,
what I'm thinking.
I think too.
The more,
Because you would think, okay, so 5, 6, 7, 8, 9.
what are the sample means?
Um,
How many of them are there?
I don't know. 1? I don't know.
I think it could. It could be C too. This is the information given. Because are we going off of the previous question, or are we?
Well, isn't the sample mean equal to the mean? Am I just
I would
okay?
imagine.
I need to sit up.
I
So
would-
I need to.
If I would imagine that A might be the first answer, or and then C.
And no, the sample means might not be the same. Look at question 4. It's got the regular mean, which is 185, and the sample mean is 176 or 177.6.
Yeah. Well, if we did it right. I don't know. I know number 6 is the law of large numbers.
It's the law of large numbers.
Yeah. I don't know number 5. Okay. The 9 organization randomly found population.
I'm just gonna guess A, but I don't know. Part of me thinks it can't be determined.
I'm gonna guess A.
Yeah, I don't know. I'll go back to that.
Because thinking about that app thing where they had like 3 different graphs,
Mm-hmm.
the second graph was always more distributed than the mean of means graph.
Let's go there.
Okay, we'll just go there, yeah. Okay, so we're on 7?
Yes.
Okay, scores. Can you turn that down just a little bit?
And scored 160. Oh, wait. Okay, you read.
Scores on the quantitative portion of the GRE are approximately normal distributed with a mean 150.8, standard deviation of 8.8. Use this information to answer questions 7 through 10. Okay, so
Diane scored 160 on the quantitative portion of the GRE. What is the z-score to Diane's score? Round your answer to 3 nearest decimals. So E equals x minus m over
So this is the one where we don't have a sample size, so we just do the regular.
right. So 160 minus 158 over.
I asked you to turn the TV down
Oh,
like 4 times.
you should have gotten my attention there fast. Is that what you want?
Seriously? Please turn the TV down.
1.045.
That's what I got. So, and that's already rounded.
Right. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So don't we just take that z-score and put it in the applet?
Yes.
1.045. And above 160, so it's just going to be the right side, right?
Yeah, so 0.1480.
Yep, that's what I got.
So just 0.148. Yeah.
Right. Okay. Random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these student scores? So do we just take the 5?
Well, we have to find the sample mean, right?
Right, so don't we do... Oh, no, that's the sample mean.
So I got the sample mean is 160. So then we take,
Right. My brain, it takes a minute to click in for a second.
and the mean is what?
163, 149, 153, divided by 5. So I got, yeah, sample mean 160. So then we just do the z-score. So don't we do 5 minus 160? No, that's, sorry, not 5.
And we do 160 minus 150.8.
Yeah, 160 minus 150.8 all over 8.8 divided by the square root of
We don't do square
160.
root. We don't have a sample size. We do.
5.
Oh, shoot. Okay, so
So, right, it's 160 minus 150.8 all over 8.8 divided by the square root of 5, right?
okay, hold on. I think so. So 2.338.
That's what I got.
I wish I was doing multiple choice.
Amen. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? I don't know.
Okay, so what is, okay, what's the probability 5 randomly selected students have a mean score? Okay, so we just have to find, so we just take the z-score, the 2.338, put it in the thing, right?
That's what I was thinking, but I'm worried that that's going to be our, like, it's our feedback one. Okay. What is the applet that 5 randomly selected students have a greater mean than achieved students? So just the right side, or is it both?
I think it's just the right.
0.0097.
Yeah, that's what I got.
So 0.009.
It says to round to 4 decimal places.
Oh, so I think we got it.
0.0097.
Okay. These are really bad odds. Okay. Suppose the mean GPA of BYUI students is a 3.5. The standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. Use this information for problems 11 through 15. What is the shape of the sampling distribution of the variable? It'll be normal, right? Because it's,
Approximately normal, yeah.
yeah. What is the mean of distribution of the sample means? For all possible samples. should we do that one? Is that the same that we've been doing?
I don't think so.
I feel like there's so many different, there's like the sample mean of distribution, mean of this, and I'm like, I don't know. I get them all mixed up.
What is the mean of distribution of the sample means for all possible samples of size 81? I don't even know what it's asking.
I don't either.
Michael, what is this asking me?
Distribution.
There's no time to talk.
You.
Okay, we'll get you chocolate milk in a second, baby.
Daddy needs to help mommy.
What is the mean of the distribution of the sample means, or sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? What is that asking me to do?
I don't know. Hold on, sweetheart. What is the mean distribution of the sample means for all possible samples of size 81? You're using pretty much the same formula the whole time, right?
Well, we have been, but it's not asking for the... Wait, what is the z-score? What's the definition of z-score? Or the x-bar, excuse me, x-bar.
Hold on. Aurora, Daddy needs to help
X-bar.
mommy. Chocolate milk.
Are we trying to figure out what x-bar is?
I have no idea what it's asking. Mean of distribution.
Okay, so...
I love you, sweetheart. Come on.
You know, I wasn't worried about the test until this lesson review, and now I'm a little worried.
Yeah. Okay, so X bar is the standard deviate. Nope. That's not it. Okay, a sampling distribution is a probability distribution of a sample statistic based on all possible simple random samples of the same size from the sample population.
You just spoke a different language.
Just reading the definition I had. Oh.
Oh, we're so close to being done, too.
Okay, so what is the mean
Of distribution.
of the sampling distribution?
For 81. So what it's asking is like, so the main mean is,
Is it just asking as X bar?
huh?
Oh, I don't know what this is asking.
So what I'm thinking it's asking is, so the regular mean is 3.5, right?
So that's the population mean.
So I think it's asking what the mean for 81 is going to be. What is the mean of distribution for sample means? 81? I don't know.
Let's get that one for a minute, if it'll let us. I don't
And
Whoa.
what's the standard deviation sample distribution of a random variable? X bar. Mean of 81 students who are selected.
I think we can get to 14, maybe.
Probably. Well, yeah, we could if we just find the z-score and put it in.
I don't think we even need the z-score.
We can do 15 too.
We have all the information, right? For 14? I don't think we need the z-score. Well, I mean, we have to find the z-score, but
Don't we need to find the z-score to put it in the probability? But don't we just have to do...
there's no way that's right.
I don't think we can do it because it says, what is the mean for 81?
Yeah.
I don't think we can. I think we have to do 12.
If you do it just for the regular mean, it's like negative 25.64, so that's not working.
Yeah, I think we have to find what the mean of distribution is for 81, and then we can do the other ones. But
Wow. How do we even do that?
I don't know. We gotta go to textbooks to find it. Okay.
Do we have to use the other website?
Whoa, it's lesson 6, distribution of sample means. Okay.
How do we not remember this?
I don't know. Like, it's complete. Okay. Okay. That's not. Okay.
Leanne just sent a message. She said the group meeting quiz is kind of hard.
No, that was me that sent it.
Oh, you?
I'm warning Leanne. She's going to want to watch our video.
What did I get? Oh, yeah, that was it. Okay. I thought she did
Okay.
it.
Introduction to sampling distributions. Please do the following. Go to the link.
It wants us to use that link.
Okay, I can do that. Click on the begin button. Okay. Oh,
What is that link? I don't have it.
when he talked about that, I was like, I don't know what you're doing. And so I kind of went, I mean, I paid attention, but I still was kind of like, I don't know what you're doing.
What is the link?
onlinestatbook.com/stat_sim.
Okay, I got it.
Okay.
I just had to look in my history. Okay.
Okay. The top graph represents distribution of the population we are studying. This is labeled the parent population. To the left of this graph is the population mean and standard deviation. We typically don't know the population mean and the standard deviation, but for this simulation, we assume they know. Okay, whatever. Before we move to the next step, go to the right of the third graph labeled distribution of means and change. Okay, obviously I'm saying this for the question n equals 5 to n equals 25. So we would change it to 81.
Okay, hold on.
No.
Okay, so what does that mean? Oops, that's not it. Yeah, it is. GPA students is 3.5. Standard deviation is 1.7. It's left skewed. You want to.
We have to figure out how this bad boy works in order to.
Daddy was on the way.
So
Yeah.
My heavens. Okay. Well, at least we're on the. Whoa. Sorry. At least we're on the road to figure.
is there any information? Because I don't think we can do that because it won't let us do a sample size of 81.
I think I need to watch the video of it. I'm going to turn it on, and you can hear it too. Okay. Preparation. Law of large numbers and distribution of sample means. It's like 5 minutes long. What the heck?
So here is the Briefing School Federal. First of all, was shape or less appropriate. As the sample size increases large. While large numbers classified as sample per population. All possible ones. Temperature is the nutrition population in then here's an example. They'll take one more here, another sample size. Houses that process 5 times. Hopefully you're starting to see the type of distribution.
I have no clue.
5
That 5 is like you times it by 5. That times it by 5. Oh, I don't know. Let me read this lesson again. It's in lesson 6 if you want to read it too.
Yeah, I am. Why was this the week that Leanne couldn't be here?
I know. Okay.
Like, I don't even know why I don't remember this.
We didn't have any questions on it. And I feel like he blew through it in the videos anyway.
Okay.
Okay, you guys are back here. What am I helping with?
Understanding what this is asking me.
Just say one
So-
with anyone.
Yeah.
Let's take a look at the question.
What is the mean of the distribution of the sample mean, or the sampling distribution, for all possible samples of size 81 drawn from the parent population? Sampling just.
So,
Oops. I'll go
so
back.
you're using all this information, right?
This information right here.
Okay. Well, because you have a large mean, and because you have a large sample, wouldn't it be the same as what you
Normal.
have for a normal? What is the mean of the distribution of the sample means? Wouldn't it be the same?
I don't know what that means. What is mean of distribution of sample means?
I don't know. I thought that was a phrase you knew.
No. So when we're looking at sample distribution, that's what we're having a hard time with, I think. So introduction to sampling distributions. And this is our intro.
Let me look at the question some more.
Okay.
What is the mean of the distribution of the sample means?
So what is
If
the
you
mean of the sampling distribution?
You Google search that phrase, mean of the distribution of the sample means.
So I get that, but I don't get how you're supposed to
So it's
times it, and I can get clear up to 80, but I can't get to 81.
yeah, you just hit sample again. Or you hit animated again.
What
And
is
it does
It
one.
does it by fives.
Oh, that's because your sample size, which is, you can't change that to 81.
Yeah, I can get 80 or 85, and that mean is 8.24. Or
But it matters, your sample size matters. Like if you have 5 versus 10 versus 25, that matters. That makes a difference. So, I forgot you had that.
Now what?
Statistics textbook. But when I hit this, when I look at what, okay, so if I rephrase the question,
Mhm.
what is the mean of the sampling distribution for all possible samples of size 81 that could be drawn from the parent population? And going to the textbook, Introduction to Sampling Distributions.
what is the mean of the sample mean?
Are you still in the central limit theorem?
Yes.
Okay, so mean of sample mean I have on page 23. Look at how much more statistics I have to go
Yeah,
through.
I know.
Wait. The distribution of sample means is a distribution of all possible sample means for a particular sample size. It has a mean of U and the standard deviation. Oh. Whatever that standard deviation over the square root of n. I thought that's what it was.
Is it cheating to watch the other group's videos?
Probably. I'm gonna go with yes.
I don't know. Would it?
I don't know. Is it? Like, is that allowed?
I have no idea. How did they do that? How do you do it? Oh, look, there's an instructions icon. Okay. This simulation lets you explore various aspects of sampling distributions. When the simulation begins, a histogram of normal distribution is displayed. The simulation is set initially sample 5 numbers from the population. Commute the mean of 5 numbers and plot the mean. Click the animated sample button and you will see 5 numbers appear in the histogram. The mean of the 5 numbers will be computed and the mean will be plotted in the third histogram. Do this several times to see the distribution of means begin to be formed. Once you see how this works, you can speed things up by taking 5, 1,000, or 10,000 samples at a time. The following statistics can be computed from the samples by choosing from the pop-up menu. Mean, standard deviation of sample. Selecting the size of each sample, the size sample can be set to. Be sure not to confuse sample size with number of samples. By clicking the Fit Normal button, you can see a normal distribution superimposed over simulated samples. You can change the population by clicking the top histogram with the mouse and dragging. That did not help at all.
Distribution. I don't know what all tools you have at your disposal. If I had to guess, I would just type it 2.5 and be done.
I have no idea.
What is the
Maybe we
name
should
of
see what Leanne thinks and just submit it tomorrow.
Yeah, we've been on this for a while. Yeah, we might have to.
What I would imagine is that because you have a sample size of 81, then your mean and your sample mean would be the same. So that means your mean, and so say you picked 10 groups of 81, for each one your mean should be the same as the sample mean. So they would all be the same. So you would have 10 sets of the same number. So the average of that would be what you started with, your 3.5. So if I had to guess, I would guess 3.5. I don't know.
Let me see.
I mean, you're talking about BPA English.
I want it.
You can't have that. It's not for baby girls. I'm sorry, Snooper. I love you.
I want it. I want it.
I'm sorry, sweetheart. Do you want another cracker? Cracker.
I have no idea.
Well, wait. Is the phrasing? Hold on.
Why can't the TA be in on this one?
Hold on. It's section 4. The mean of the distribution of sample means. The following facts are always true. They do not depend on the central limit theorem. They do not depend on the sample size. These facts hold for the sample mean x bar of any simple random sample of size n drawn from a population with the mean mu and standard deviation sigma. The mean of the sample mean is mu. The standard deviation of the sample mean is sigma over square root of n. So the mean, let me go back now, because I have like 17 billion things open.
So do I.
So it would be 3.5.
Your husband was right, and he did it in his head.
Yeah,
Ugh.
well, he's a genius, math-wise. His job is to tutor people at math.
So are we just gonna put 3.5?
3.5.
I don't know. I mean, I didn't look at the program you're using. That's just my guess.
No, because
I've only taken one statistics class.
it's not even the program. The mean of the sample mean is mu.
Yeah.
It says right here. So I'm not even using the program.
Well, that program was dumb. Okay. And I said it on camera.
Okay, what's the standard deviation of the sample distribution of the random variable x? So that's sigma over square root of n. So sigma is 0.7
Over
81.
81.
Square root of 81, right?
Square root of 81 is 9.7. Oh, my throat.
So 0.078.
Yep.
Took us that long to figure that out. That is just equal to. Oh, I hate this.
Would it be 0.088?
For which one? 13?
Mm-hmm. Because you're rounding.
0.078. Round to 3 decimal places.
Oh, you're right. I'm sorry. My brain's struggling. It's getting really late here. Okay. Okay. What is the probability that the mean GPA for 81's randomly selected BYU students will be less than 3.3? Don't we just need to put that in there?
So that's what we were doing earlier, right?
I think. So the number.
Hold on, let me see if there's one like it. There's not.
I think isn't that the one where we just find the z-score, enter it in.
I think so. So we use the sample mean, which is 3.5.
81, right? So it's 81 minus,
No, it'd be 3.3.
sorry, 3.3 minus 3.5, right?
Yeah, over 0.7 divided by the square root of 81. Right?
So 3.3 minus over 0.7.
No.
Negative 2.571.
Hold on just a sec. I got negative 2.564.
Let me try it again.
3.3 minus 3.5 equals negative 0.2.
Wait.
0.7.
Equals negative 0.2. What? Isn't it over 0.7 divided by square root?
I was just, because we got different answers, I'm doing each step. So 3.3 minus 3.5 equals negative 0.2. And then 0.7 divided by the square root of 81 equals 0.078. So then negative 0.2 divided by 0.078 equals negative 2.564.
That is not what I got. I got negative 2.571. 3.3 minus 3.5.
Mm-hmm.
Okay. Because I just entered it all in my calculator. 3.3 minus 3.5, close parentheses, over 0.7 divided by the square root of 81. Negative 2.571.
That's not what I'm getting. 3.3 minus 3.5 divided by 0.7 divided by the square root of 81. Yeah, I'm still getting negative 2.564.
What the heck? You literally said exactly what I did.
Negative 2. And then you're doing 0.7?
Mhm.
0.7.
So what are you getting for your answer for 3.3 minus 3.5?
Negative 0.2.
That's what I got.
Okay.
0.7 divided by, I'm doing it your way now. 0.077 whatever 8. So 0.078.
Yeah.
That's probably the difference then, because you're doing I don't know, maybe not.
Let me do it this way.
Because I get negative 2.56 when I do it that way too. But when I literally entered the entire formula in the calculator, 3.3 minus 3.5 all over 7 divided by the square root of 81.
Okay, let me try doing it your way. 3.3.
That is so weird.
Negative 2.571. Doing it all together.
Yeah, that's what I got. Why does it do that? The only thing I can think of is,
It's a rounding error.
huh?
It's just a rounding error.
Yeah.
Okay, anyways, well, that was just the z-score, right? So we still have to enter it in.
So negative 0.257, is that what you're putting in?
The probability thing,
The z-score, yeah.
I'm just doing negative 2.571, just doing all of it.
Okay, that's fine.
It'll be less than 3.3. So so 0.0051.
So do we do less than 3.3, so we just do the left?
I think. Because our answer was negative.
So you said, what did you say?
0.0051 is the answer I get at the top, so we'd still have to round it, I think. So 0.005. Is that what you're getting?
Hold on. Did you put 0.257 in the z-score?
But it's negative.
Well, that's what I meant. Yeah.
Yeah. Well, I did 2.571.
Two, 5, 7, 1. That's what I did.
Negative 2.571, right?
Right. And then you just highlighted just the left.
Yes. So it's a really, really tiny triangle. And the area is 0.0051.
That is weird. That's not how mine looks. Look at mine. I'll show you.
Okay.
What are you doing? Where are you? See this?
It's because you're doing point. It's negative 2.571.
What?
The answer is negative 2.571.
That's not what I got. Hold on.
I mean, I can show you my calculator.
Oh, I believe you.
3.3 minus 3.5 divided by 0.7 divided by the square
Oh,
root
I see where I messed up. Sorry, I put 7. I didn't put the point on there. Like, that is not right. Okay, yeah.
Isn't it point? Is it supposed to be point? Let me look. Standard deviation.
No, it is 0.7.
Okay, 0.7, yeah.
That's where I screwed up. I wrote it so many times I forgot the, okay. 2.571. That's much better. 0.0051, right?
Yeah, so when we round it, it'd be 0.005.
Okay. Okay. That was weird. Okay, 15.
This is taking us so long. Okay, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3?
So is it the same? We just have to highlight the greater side, right?
Yeah.
So 0.0051 or 0.005. And the other one was negative 0.005, right?
No, so it would be 0.9949.
What?
So what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? So we keep the same numbers, you just select the other two sections and unselect the one.
Oh, okay. 999 or 994.
9949 is what I.
Yeah, I know. We have to round it.
So 995.
5.
0.995.
995. 0.005.
Where are you getting 0.005? Oh, for 14.
14, sorry.
And then 15 is 0.995.
Right.
Okay.
That was so awful. And I will cry if we do terrible on this. But at the same time, what can you do? Admitting, I'm scared.
I'm
Hey,
scared.
hey,
Huh?
you got an A.
100?
Missed one.
Oh, fun.
It is an A on 5. It is B. This distribution of the sample means. Oh, that's a relief.
So that was the one that we were just like, we don't know, so we're just going to guess A.
Yeah,
We were guessing A or C.
but it was B.
Oh, anyways. That
Good
was terrible.
That was so long. And just think, Leanne has to watch it all.
Hey, at least she'll get an A.
She wants the answers. She's gonna get on and be like, I hate you too. You can't hate us. We did your homework for you.
Oh, that was horrid. Horrid.
Okay. That took us 2 hours.
Yeah. Hey, but at least we got it.
We got an A, so that's all that matters. So, good. Glad to know we kind of know what we're doing.
Even if we stumble through the whole thing. Well, as far as I can tell, let me open this back up. Week 4, lesson 8 is the review for exam 1.
This one was a big review too. We did a lot of stuff, but yeah.
But now we have to know what we just did and everything else.
Yeah. So Brother Ball's replied because all of our HOA titles are I hate. Just or I hate Google Hangouts. He says, I'm sorry you hate this.
I responded to him. I was like, maybe you can show us how to do this because we suck at it, basically.
Yeah. Anyway. Alrighty. Sounds good. I will post this video.
We should just have you be in charge of it every week because I cannot figure this out.
I don't know why it works. It works for this computer. I'm on my husband's laptop and it's brand spanking new, and that's the only reason why I think it works. I don't know. I don't know why that would do it, but
When I send you the thing, it doesn't work.
yeah, I don't get it.
Like I go to the Hangouts on.
I get the described when I sent it last week.
I go to the
And last week I tried to send it to you. I sent it through my desktop, which is like 5 years old, and you wouldn't get it. And then when I started doing it through my husband's laptop, it suddenly started working. I'm like, okay, clearly the laptop's the magic worker.
Yeah, because I mean, I would go to the Hangouts on Air page, and then I've tried it both ways to say, okay, we'll start later or we'll start right now, and
Yeah.
either way, you don't get it.
Yeah. Mine, I just started doing it, let's do it right now. And then when I do it right now, it works. But when I set up a meeting, it doesn't work. I don't know. It's over.
Yeah.
So I'm fine starting them. It's not that hard to post it. Now, if I do like a questionnaire every week, I'd say, this is bullcrap. But
Yeah. No, you just post it.
yeah, it's not a big deal.
And it's just the three of us anyway, so it'd be, every 2 or every 3 weeks you'd have the assignment anyways.
It's not a big deal. Alrighty. Let's plan on next week. We have a test next week.
Yes.
Alrighty. Awesome. Sounds good.
Okay, so
Contact. I figure Tuesday probably, right? Yes, though. Monday.
she was transporting a prisoner.
What?
Yeah, she said, I told her it took 2 hours, and she said, wow, how did y'all do? Sorry, I was transporting a prisoner. I'm glad I don't have her job.
I'm nosy. You'll get my text in a minute. Okay.
Yeah.
Okay, so the February 1st through Wednesday. Oh, we probably should meet Monday.
That can Leanne meet?
I don't know. I mean, I guess we can meet Tuesday, and we'd all just have to take the test Wednesday.
Is the test due on Wednesday?
Yeah.
Oh, okay. What was the question we missed? Number 5?
5.
Okay.
Okay.
Okay, so we should meet on Wednesday. Or on Monday, not Wednesday.
Yeah, probably. Yeah, that's what I think. Study all of us Monday, or we can study together on Monday, and then we can all take the test whenever we want.
Okay, and is Leanne going to be able to be there on Monday? Because I know she sent us her schedule thing, right? Let's see. Monday is the 1st. So, let's look at the picture. Oh, come on. It won't let me go back that far. Let's see.
She sent us a picture of her. Let's see. 1st, 4 p.m. She works 2nd too. She doesn't work Wednesday though.
Does she? Okay, when does she work on the 1st?
4 p.m., 4 a.m.
So now she's not going to be able to be there.
Mm-mm. She would be sleeping in the daytime too if we just tried to meet in the day. And that would be chaos because of my kids.
Yeah. I mean, when we start, it's only 6 o'clock here, and so Aurora's just running around everywhere.
Yeah. I understand. I have 3, so.
Yeah. I just got one. And she's pretty good for the most part. Especially if you just put a movie on.
That's how mine are, except for I have a 1-year-old and she doesn't really care about movies.
Yeah.
Alrighty. I'll get this posted.
Okay. Happy anniversary.
Thank you.
Welcome. How long have you guys been married?
7 years.
Yes. You've been married 5, almost 6. So we're right behind you.
Yep.
So, all right. I guess we'll just text and see when we can meet on Monday.
Okay.
Okay. Sounds good.
Good. Talk to you later.
Bye.